In this video, we're going to take a look at a programming languages comparison between both Java and Python. We're going to go over these following topics. So we're going to go over array, dynamic array, hash table, heaps, sorting, stack and queue, string, exception handling for both languages. We're going to do a side-by-side comparison for both languages syntax. And basically, this video is more for people who have experience in one language, want to transition from one language to another, or just want to do a side-by-side comparison of both. So I will make sure to put the code in the link down in the description. So now let's start with the first one. Now before we get started, I do have a playlist called Algorithms and Data Structures, which I cover pretty much all the data structures and algorithms that you should know. So if you're interested, please check it out. So the first topic we can take a look at is array. So we're going to take a look at how we define 1D, 2D, 3D array in both languages. And you can see that for Java, we first have to define the type, right? In this case, it's an integer array. And then you can see that for this integer array, we have 3 values, right? And you can also define it this way. So basically, once we initialize the 1D array, we can be able to, we cannot be able to add additional element, right? So I cannot say array at index 3 is equal to something else, right? Because there's, in this case, the array is fixed size, right? There's only 3 elements in the array. Whereas Python, you can see that we can be able to actually change it. And there's no fixed size for the array, right? And then you can see here, if I want to fill the array with values, with a specific value, right? So I define the array, and then I say arrays.fill, and then I pass in the array, and I pass in the value that I want to fill. So what I will expect is, 5 threes, right, in one array, right, in this one directional array. Whereas Python, you can see that we're doing the same thing, but it uses something more like a times, kind of like math symbol, where you put this symbol is basically multiplication symbol. Basically means that we're going to times this, we're going to get this value duplicated a number of times, right? So you can see we get 3 5s in the array. And then for 2D array, it's kind of similar, but because arrays.fill, you can only fill just one directional array. So you have to iterate all the rows that we have in the matrix to fill each and every single row with this value. So for 2 directional array, basically it's pretty much the same thing. For this array right here, we're gonna create this array m number of times, right? So m is basically 5, so we basically create a matrix that's 5 by 5. And then what you can also do is you can do array of 1, right? Basically you're adding this array m number of times, right? And then same thing for 3 directional array. So first you basically create this array, and then you're just creating that array m, or in this case m number of times. And then for this number of matrix, you want to create it k number of times, right? So you're creating k number of matrix. Whereas Java is kind of the same thing as well. Like you do the arrays.fill, right? You fill the array with a specific value, right? And then you do that for, in this case, m number of time. M is basically number of rows. And then you can see that we also have matrix, right? So in this case, we have k. We're going to iterate k times to create k number of matrix, right? So at the end, we will expect a 5 by 5, or 5 times 5 times 5, right? So it's like a 3-directional array. So basically, you can see that this is how we initialize multi-dimensional array in Java and Python. Now let's take a look at dynamic array. So basically, you can see that in Java, we use collections for dynamic array. So in this case, collections, we don't have to define the size, right? So you can see that under the collections class, we can have set, list, map, sorted set, hash set, and so on, right? And under list, right, list, which is under collections, and list, you can see we can have set, array list, linked list, and so on. So in this case, we can also define a pre-existing value. So you can see that we initialize the array list, right? First, in this case, the list variable has a type of integer, right? So it only takes integer value. And you can see that we define it here, and then we pass in the existing values, pre-existing values in this list. And then if I want to insert a value, I just call the .add function, which passes in the value that I want to insert. It will insert onto our list, right? So it will insert last. So in this case, after we insert this value, the list will be 1, 2, 3, 4, right? And then when we delete that value, in this case, we pass in the index. We can also pass in the object that we want to delete. So we can pass in the index that we want to delete. In this case, we want to delete the first element. In this case, is 1. And then we can also access an element. So list.get index. So that will print the element. In this case, will be element 2, right? For Python, it's kind of similar. So we use basically this array. So we can insert a value by just calling .append. We pass in the value, it will just append that value onto our list. And you can see we also can be able to delete a value. Basically, you define which index that you want to delete, it will delete that value. And if you want to access an element, in this case, we can just print, right? Or in this case, list at index, which will retrieve that value, right? So basically, this is dynamic array. This is how you do insertion, deletion, and access. So now let's move on to the next topic. Let's take a look at Hashtable. So in Java, you can see we are using map, right? So you define the type for the key and then for the type of the value. It doesn't have to be integer. It can be string, can be boolean, can be anything else, right? And in this case, you can see if I want to insert a value, right? In this case, this is the key, this is the value. I'll just call it hashmap.put, right? I pass in the key, I pass in the value. So the first parameter is the key, the second parameter is the value. And if I want to access an element, basically I'll just say hashmap.getKey, and it will retrieve the value inside this table, right? And let's say if I have a value that doesn't exist, then I would just say hashmap.get or default key +1, map +1, value +1, right? So because in this case the table doesn't contain this key, so by default it will return this value, right? If we cannot find this key in our table, okay? And then for Python, it's kind of similar, right? For insertion, right? For insertion in this case, it's kind of similar to array. So for this inside the dictionary, right? For this key is equal to value 1, right? If I want to retrieve an element, in this case, I can say, okay, hashmap at key 1, this will print the value, right? Which is value 1. And then if I want to retrieve a value that's not there in the table, you can see we just do hashmap.get key 2, and then if we cannot find that key in our table, we just return value 2, right? So let's say if I want to be able to save this value, right? In this case, if I want to save key 1, right? Sorry, key +1, right? If I cannot find this key, what's going to happen is that first I will try to see if I can be able to find it in our table. If we cannot be able to find it, we can just assign value +1 to key +1, right? And you can also do the same thing for Python. Is you can just say hashmap.key2 is equal to basically hashmap.get key2. If you cannot get it, we just return value 2, right? So this is pretty much how we use access insertion in Hashtable. And for deletion, it's kind of similar. So you just say hashmap.remove. You pass in the key that you want to remove, and it will remove that. And then for deletion, it's kind of similar to how you did it in array. So you just say delete table at this key, right? And then we can also use table to check to see if a key contains a specific, or I should say a table contains a specific key. In this case, we just say .contains key, which it will return a Boolean function to see if it's true, right? If it's true, that means that if the map contains a mapping for a specific key, right? And then for Python, the same thing. You can just do in, right? So we check to see if key 2 is in hash map, right, or in the table. If it is, that will be returned true, right? And you can also see that we can also iterate the table, right? To iterate the table, we just say hashmap.keyset. which basically you can see we're just basically iterate all the keys that we have in our table, right? For each and every single key, we can be able to say hashmap.get this current key, which will give us the current value. And you can see we're just print it on the console, right? And then for Python, it's kind of similar. We iterate each and every single key. The value in this case is equal to hashmap at current key, right? So you can see it's pretty similar to how we access element in the array for table in Python. So now let's move on to the next element or the next topic. So now let's take a look at heap in Java and Python. So in this case, you can see that in Java, we use priority queue to define heaps. We can be able to define min heap and max heap, and basically we define a max heap by defining a comparator that basically you can see that we're using a descending order, right? In this case, for those two arguments, we're basically going to have b minus a, right? If it's b minus a, that's basically descending order. If it's a minus b, that's basically ascending order, which is basically a min heap, right? So you can see that we can also insert values onto the heap like this. And then in this case, we have a list, we can pass that in, and by default, priority queue will think that this is a min heap, right? It's going to be ascending order. And then you can also see that in Python, it's kind of similar. We use a list, right? This is min heap, and we call this heapify function, which basically heapifies this array or this list, right? And then this will give us a login time complexity, right, for calling the heapify, which basically doesn't sort the array, but basically keep the smallest element at the first in the array. And then you can also see that for max heap is kind of similar, but it has this like max heapify max function, and you pass in the list, and then basically it heapifies this list, which is also login time complexity. And then we basically keep the largest element at the first in the array, which is basically 9, right? And then for insertion for both, it's also gonna be login time complexity. In this case, we say min heap.add, we add a value, right? In this case, it's 9. And then in this case, for Python, it's kind of similar. So in this case, we do heap push, right? We pass in which heap. In this case, is min heap. In this case, we're inserting 10, right? So once we insert it, we basically calls the heapify function. It will try to basically, balance balance the heap, right? Which basically keeps the smallest value at the top for the min heap. In this case, is also going to be login time complexity. In this case, you can see that for max heap, in this case, it doesn't really have that option, right? So we basically have to append it, and then we call this this function, which basically heapifies the max heap, right? And then for Java, it's kind of different because once you define this, right? Once you've defined the comparator, you can just add a value. It will just heapifies it for you, right? And then you can also be able to access element. In this case, because this is a list, right? You can pretty much access all the element, but it's kind of like a list. You can access the index. You can access the element by calling the index, right? Basically, either for min heap, the smallest element will be at the top, right? Basically, the first element in the list. For max heap, the smallest element will be the first element in the list, which is the largest. And then for Java, it's kind of similar. You just do .peek, call the .peek function. It will basically splits out the either the smallest or the largest, right? And you can also delete an element. This should be pool, it shouldn't be peek. So in this case, you can be able to take out the top element in the heap by just calling .pool. So for deletion in heaps in Python is basically similar. We basically call the heap pop function, which basically removes the smallest element in the min heap. And then in this case, the heap pop max function to remove the maximum value out of the max heap. And then after that function, it will basically just rebalance the heap itself. So that we make sure that for min heap, the smallest element will be the top or the first element in the list. And then max heap will the maximum value will be that the first element in the list, right? So now let's move on to the next element or the next topic. So now let's take a look at sorting. So in this case, for sorting in Java, we can use a list or a array, right? In this case, you can see for list, we have an integer list. And then for array, we have an integer array. And then we also have a object array. So you can see we have a class or a type user, which basically has only one property, ID, integer ID. And then in this case, we have a toString function so that once we print it, it will basically print the string version of the ID, right? And in this case, you can see we basically have a array of user. So we have we have one list and two arrays basically. So in this case, if I want to sort in ascending order, I would just say collections.sort for the collection. If I want to sort the arrays, I would say arrays.sort, right? And then we will basically print that out. And then you can see that for array of objects in Java, you can see arrays.sort list 3. And then you basically pass in the comparator, right? So just like the maxi that we just talked about in the Java, basically we use a comparator to define how we're going to sort it, right? So you can see that for those two objects, we're basically sort by ascending orders based on the ID of those two objects, right? Based on the object's ID. And then we will print it. But for Python, it's kind of similar. Basically, you can see we have a function that basically tells how we're going to sort by. So you can see we have two array or two lists. In this case, one list is just an integer list, and the other one is an object list, right? So you can see we have ID and it has a value of 3. And then in this case, we're basically sorting ascending order. So you can, in this case, for list 1, it's pretty easy. We just say .sort. But if you want to sort by a key, right, or for object, you want to sort by a key, in this case, or sort it based on a specific function, right? So you can also sort by the size, or in this case, it's the size of the string, or so on and so forth, right? So you can say key is equal to sort by, which is this function right here, which returns basically sort by the key, right, of the objects. And then we print it, right? And then for descending orders, the same thing. What we can do is we can just say collections.reverse order, basically sort in the descending order, right? And then we print that in the console. And then same thing for arrays, right? In this case, arrays.sort, and then we just say collections.reverse order as well. But in this case, for array of objects, what we can do is we can just do a comparator. Instead of A minus B, we can do B minus A, right? Which basically represents descending order. So now you can see that when we're in debug mode, we have two array defined and one array list defined, right? And then what we're gonna do is you can see we're just gonna say collections.sort. It'll basically sort those elements, right? So now we have 3, 1, 2. So if I continue, you can see we have 1, 2, 3, and then we print it, right? And then in this case for list 2, we also sort it as well, right? For list 3, we sort it in the ascending order. We do that as well, right? We basically, when we print it, we only print the ID, right? And then in this case, if we want to do a descending order, we can do the same thing. We just call collections.reverse order, and we will reverse the order of the, basically sort in reverse order, right? And then same thing for the list 2, right? And for list 3, we do the same thing, and you can see that we're sorted in descending order. So now we have 3, 2, 1, right? So now let's take a look at Python. For Python, it's kind of similar. We basically source the list 1, right? So once we sort the list 1, you can see we're sorting in ascending order. And then for list 2, we basically sort by this function. And then in this case, we're sort by the key, right? In ascending order. So now once we sort it, it will print something like this, right? And then for descending order, we basically have to say reverse is equal to true, so that we can be able to sort in reverse order. And then we're going to print list 1. Okay, and then for list 2, the same thing. We're just going to sort reverse order is true. And then for key, in this case, we're sorting by the object ID, right? and then this will basically print the object. In this case, we're getting a reverse order of the array. So now let's move on to stack and queue. So now let's take a look at stacks and queue in Java and Python. So basically, stack is last in, first out. So in this case, the last element in the stack, it will be the first element out of the stack, right? And then the queue, in this case, the first element in the queue, and then is also the first element out of the queue. So basically, you can see that for stacks and queue, they all have type integer. And then in a stack, in this case, is basically they use stack, but for queue, in this case, they're using linked list, right? And then for insertion, in this case, we just do .push for stack, and for queue is basically .add, right? And then for remove, for I should say deletion, in this case, it's just gonna be stack.pop. For queue is basically queue.remove, right? And then for Python, basically they're using list still, right? So you can see that for this element right here, we basically append it onto the stack. And for stack, it's basically stack.pop, right? So it basically pops the last element that was inserted. For a queue, we can just say pop at 0, at index 0. We basically just pop the first element that was inserted in the queue out of it, right? So now let's take a look at string. So for string, it's also kind of different. So you can see that in Java, we define a primitive type string, right? So this is basically a string. And then in Python, it's kind of the same thing. So if I want to convert string to a number, I just say integer.parseInt. It will just convert it into an integer value. And for Python, you just say int, and then you pass in the string. It will just convert it into a number. And then if I want to convert from number to a string, you can also do the same thing. You do integer.toString, which basically converts the number to a string. But for Python, you just basically put string and then you pass in the number inside, right? So that will basically convert anything that you pass in here to a string. And then in this case, for string to character array, we just say string.toCharacter array. But this one, it was just say you pass in the string, it will convert into a list. And this basically is a character array, right? So for string comparison in Python, it's different. So you can see that if I want to see if those two is pointed to the same address in the location in the memory, in this case, we check to see if s is equal to this, right? We just do the opposite of Java, right? So we check to see if s is this. We check to see if they're pointing to the same allocation in memory. But if I want to see if those two strings has the same content, I will just do this, right? So s is equal to 1, 2, 3. If it is, it will return true, right? And for Java, it's kind of like the opposite. So strings dot equals, which basically check to see if they have the same content, right? And then strings is equal to this basically means that we check to see if they are pointing to the same allocation in memory. Okay, so that's kind of like a little bit different there. And then the other thing is the substring. So in this case, you can see that we can say string.substring, which basically from index 1 all the way to the end, right? And then if I also can be able to specify the ending of the substring. So in this case, I want to go from index 1 to the end including index 3, right? So this will give us a substring out of that. And then for Python, it's also similar, right? You can just, instead of like dot substring, we basically treat it as like array. So from 1 to the end, or you can also do from 1 to 3, right? From index 1 to 3. So that will also work. Now let's take a look at append a character onto the string, right? So in this case, if I want to append a character onto a string, I can use the string builders, or I can just do what Python did. I can just say the current string, in this case str, right? str plus equal to character 0, or just string 0, right? Or we can just do character 0, right? So I can do character 0, I can append like this, or I can use a string builder to append the character, right? I can also append a string. I can also, in this case, I can append a string like this, right? I can also append a character like this, right, in Java. But basically for string builder, we can be able to call this append function in constant time complexity. So it's kind of like a stack, right? You kind of just append it onto the current string, right? The current string in the string builder. And then if I want to print it, or if I want to convert it back to string, it will be a linear time complexity for just converting it to the string. Whereas Python, it doesn't really have that option, but you can definitely use a stack, or basically just to push it onto the list, and then one by one, right? Now let's take a look at exception handling in both Java and Python. So in this case, for Java, you can see that we use try catch, whereas Python, we use try except, right? So in this case, basically what's happening is that everything that happens in the try, if there's an exception, we basically catch that in the catch function, and we can be able to print it out or do something about it. And then we can also, in this case, the finally basically means that after the try catch, it will go through the finally, right? So in Python, it's kind of similar. You can basically, if there's anything happens, if there's an issue, if there's an error, we catch it in the except. And then the finally basically handles, basically is the function that we go after those two, right? So you can see that for Java, if I want to throw an error, in this case, I just say throw new exception, I pass in the message, and then I can be able to catch that message, right? I can be able to print it in the console, right? Just called .get message, which is basically invalid input, if that's the case, right? If this condition is not the case, then we will not print it, right? And finally, it will basically just print this to say the try catch is finished. For Python, if I want to throw an error, it will basically say raise value error and pass it a message, and then it will basically, you can be able to catch that in the except function, and then it's basically value error as an error, right? So you can basically treat it as a string, and then we can print it on the console. This is it for this video. As you can see, this is just a brief comparison between two languages' syntax. If you want me to do any other programming language syntax comparison, please leave a comment down in the description. As you can see, that this is just a syntax comparison for two languages. There's also other factors that we have to consider, like the security of two languages, performance, scalability, maintainability. So there's also other factors that you want to consider when you're choosing a programming language. But this video, we're just focusing on the syntax. So if you want me to make another video about other factors for other programming languages or this programming languages, please leave a comment down in the description. And if I were to make another video, please make sure to check out this playlist for related to programming languages comparison. Other than that, thank you for watching.